Welcome to EPG Pathshala lecture series on data analytics. In this session on data analytics, we will be discussing about non-relational databases. The objectives of today's session are to get a good idea about database designs and decisions related to database designs by making use of non-relational databases, and also understand what is the difference between relational and non-relational databases with respect to database design. We will also get to know about different types of NoSQL databases and then compare NoSQL databases with each other and relational databases systems. So, to begin with, first we should understand what is the current market need. Currently, the market is driven by lots of social media data. So, we can understand we require certain databases or storage environments that can handle explosion of social media sites like Facebook, Twitter, etc., which are going to handle large data needs. Explosion of storage needs in large websites such as Yahoo, Google, Microsoft, etc., requires large databases which can actually work in clusters or groups of clusters. Databases which are capable to handle or tune with the 21st century websites. Why we talk about 21st century websites are they are schema-less or they are majority unstructured in nature, and these 21st century websites are without large relations and mostly for open sources. So, the current market need is to have databases that can deal with voluminous unstructured data. Now, let us understand what is the power of NoSQL. Before knowing the meaning for NoSQL, let us know why it is actually required. When you make use of a non-relational database, now based on the current need, we can understand non-relational databases becomes very easy and ready to manage with clusters. They are suitable for upcoming data explosions. In other words, they can handle very large data. It is not required to keep track of the data structures, because in many scenario it is going to be structureless. And finally, NoSQL type of databases provide easy and flexible way by which you can handle and manage data. So, now let us understand what is a NoSQL and what are the characteristic features of this NoSQL. NoSQL means not only SQL, implying that when we are trying to design software applications or solutions or products, there are more than one storage mechanism that could be used based on the needs. For example, when you are dealing with say data that is from the web, we find multimedia data which is completely unstructured in nature. You need to transform these unstructured data into a structural environment. In certain scenarios, we deal with time based data like time series data or sequence data, or in some scenarios we even depend on the relational data. So, the structure of the data is not at all known. The mechanism by which you are storing is also completely ad hoc in nature, and we require a broad set of mechanism or frameworks which put together can be called as not only SQL or NoSQL, which can handle such unstructured data. Now, the characteristic features of these unstructured handling mechanisms put together, which can be called as NoSQL type of databases, have certain characteristic features like auto sharding. We will discuss about what is auto sharding in the forthcoming sessions. Here I would like to just brief about what is sharding. Sharding is fundamentally splitting the data and putting it multiple machines, so that the data may be made available at any point of time. The second important characteristic feature is distributed query support. Suppose a given query is going to work on say a voluminous data, assume the data is distributed in different nodes, maybe across even different geographical locations. In such scenarios, running the query on a single node becomes very difficult. Therefore, you need to run the query in a distributed fashion. Sometimes the queries may be subdivided into subqueries and then sent to the respective nodes that is available in different geographical locations. get the results, merge them, and then finally project one single result for the given query. This is actually an important feature supported or provided by NoSQL type of databases. Then the third but very important characteristic is integrated caching. Integrated caching is what is essential for fast accessing of data, and hence it makes the data available very quickly, and auto sharding and distributed query support makes the data available at any point of time. So, with these types of characteristics, now it becomes easy for us to handle any type of data in any region. Now, let us understand where the NoSQL is being used. NoSQL is currently being used in various scenarios. One important place where NoSQL is used is Google. In Google environment, we can find the usage of Bigtable and Level DB, which are one type of NoSQL databases. In LinkedIn, they make use of Voldemort, which is another type of NoSQL database. Then we also find NoSQL type of database called Cassandra, which is used for Facebook as well as Netflix. Twitter also makes use of Cassandra. Apart from Cassandra NoSQL type of database, it also makes use of FlogDB, Hadoop as well as HBase. CERN is also making use of another type of NoSQL database, which is called as CouchDB. When we talk about all these applications or areas where NoSQL is being used, we can understand all these environments involve voluminous data as well as their data being distributed across different nodes. So, now we can understand why NoSQL frameworks or NoSQL type of databases is applied in these domains. When we talk about the different types of NoSQL databases like the one given in this slide, like Bigtable, Voldemort, Cassandra, Hadoop, HBase, FlogDB, SimpleDB, CouchDB, etc., all these are all one type of NoSQL databases. Each and every type of database has its own properties and features. We will be discussing about these types in later part of this session. Now, let us understand how this NoSQL has evolved over a period of time. Actually, in 1998, the term NoSQL was coined by Carlos Trozzi, and this name was used for a lightweight open source relational database that did not expose the standard SQL interface. Then later in 2000, Neo4j actually started a graph database for its own applications and backend process. Google came up with Bigtable in the year 2004. Then a type of document database called as MongoDB was started in 2007 as part of the open source cloud project, cloud computing stack, and first it became the first standalone release in the year 2009. Facebook came up with Cassandra project in 2008. Project Voldemort was started in the year 2008, and the term NoSQL was then reintroduced in early 2009. Now, this is the evolution of NoSQL databases. Now, let us understand how these databases, especially the NoSQL databases, are popular and how its popularity is growing by using this chart. Earlier in 2013 and 14, a survey was conducted and statistics was identified, which said 32% of the applications were using MongoDB, which is one type of NoSQL database. 28% were making use of Oracle, 23% of the people were making use of MySQL, 5 and another 5% of applications or other people were trying to make use of Cassandra as well as HBase. But when they took the same survey in the year 2014-15, they found there was a steep rise in terms of usage of and applications of NoSQL databases, which can be easily seen from this pie chart. See here, originally Oracle and SQL were having 28% and 23% respectively. Now, in 2014-15 you can find there was a decrease in terms of the usage of the relational databases like Oracle and SQL, but you can find there is an increase in the usage or applications of NoSQL databases based on this survey. Now, this shows NoSQL databases are finding more popularity when compared with regular and traditional relational databases. Let us understand what is the difference between relational database management system and NoSQL. When we talk about relational databases actually support powerful query language, which is not at all available in NoSQL database. Not at all here in the sense the query language is going to be very simple. Anyone can easily understand and make use of it for the purpose of querying. Secondly, relational databases have fixed schema, which is not present in terms of NoSQL environment. That is, there is no fixed schema. Relational environment follows ACID property, atomicity, consistency, isolation and durability, but in NoSQL environment we follow an eventually consistent property. Eventually consistent is in due course of time the images in your databases, images here in the sense the data, will be made consistent. Lastly, relational database environment supports transactions, but NoSQL type of databases do not support transactions. These are the major differences between RDBMS and NoSQL type of databases. In the previous slide we understood relational databases were based on an important concept called ACID concept, but NoSQL database is based on another important concept called CAP theorem, also known as Brewer's theorem. What is CAP? CAP is an abbreviation for consistency, availability and partition tolerance. What do you mean by consistency? The database need to be consistent, and when this consistency will be achieved is after execution of an operation. So, data in the database remains consistent after the execution of an operation. This is called as consistency. Availability is the system is always on and there is no downtime. In other words, data as well as the application is going to be available 24/7. The third abbreviated component P is partition tolerance, meaning the system continues to function even when the communication among the servers is unreliable. In other words, the servers are actually partitioned into multiple groups, and these multiple groups need not be in a position to communicate with each other, but still then the communication is always up. Now, why we talk about this CAP theorem is all the NoSQL databases are designed based on this Brewer's theorem or CAP theorem. In other words, NoSQL databases must satisfy the CAP theorem or CAP properties. In this slide, we can see the three properties: consistency, availability and then partition tolerance, indicated as three different sets. The intersection of these sets result in various requirements like the CAP requirements. The combination of consistency and availability is indicated by the overlapping region of availability and consistent set. CP is consistency and partition tolerance, which is represented by the overlapping region of consistency and partition tolerance set, and AP is availability and partition tolerance. This is in the region of overlapping between availability and partition tolerance. So, what does it mean? We get three combinations of these CAP properties. The first combination is consistency and availability, that is, it may be a single site cluster, therefore, all nodes are always in contact. In contact here in the sense they are always available. Since it is a single site cluster, the data is going to be consistent enough. The second combination is consistency and partition tolerance, where some data may not be accessible, but the rest is still consistent and accurate. The third combination is availability and partition. In other words, the system is available under partitioning. Why the system is made available always is based on the partitioning, but some of the data returned may be inaccurate, that is the consistency property is not retained. So, in the first scenario partitioning is not mandatory, in the second scenario availability is not mandatory, and in the third scenario consistency is not mandatory. According to the NoSQL databases satisfying these criteria, different types of databases, NoSQL databases comes into picture. For example, RDBMS is closely related with consistency and availability of data. The objective of NoSQL databases like MongoDB, HBase and Redis are associated to consistency and partition tolerance. Other NoSQL databases like CouchDB, Cassandra, DynamoDB and RISC are associated to availability and partitioning. So, this diagram over here indicates various types of CAP requirements and the type of NoSQL databases that satisfy these CAP requirements. Now, what is the base for this NoSQL type of database? Similar to ACID, base is basically available, soft state and eventually consistent. So, B stands for basically, A stands for available, S stands for soft state and E stands for eventual consistency. Basically available means even the system goes down, the data is made available. So, what does it mean? It is always made available to the application, the data is always made available to the application. So, this satisfies the CAP theorem. Soft state, the state of the system may change over time even without input, that is the consistency related to the data may change over time and the consistency may come into picture only after say a particular program or a particular action has taken in the given database. So, it becomes eventually consistent, that is the meaning of it, the soft state. What do you mean by eventual consistency? The system will become consistent over time given that the system does not receive any input during that particular time. So, put together the system looks in for a duration where there is no input and at that point of time the system makes itself consistent with respect to the given data. So, to differentiate between acid and base property, we find acid is atomic, consistency, isolation and durability. Base is basically available, soft state, eventual consistency. NoSQL databases must satisfy the property called base property. So, when it satisfies the base property, the CAP requirements are also satisfied. There are different types of NoSQL databases. The NoSQL databases in general can be broadly classified into 4 types. The first type is key valued store, second type is document based store, third type is column based store and fourth type is graph based store. Under key valued store, few databases like Amazon S3, Dynamo, React are all key valued stores. Couch database is a type of document database. HBase and Cassandra is a type of column based store. Neo4j is a type of graph based database, NoSQL database. Now, let us understand in detail what is key valued, what is document based, what is column based and graph based type of storages. When we talk about key value store, it actually has the data in the form of a row. So, when you try to update the information, all you require is a key and the corresponding values. So, when you are trying to add or modify a record which is available or which is stored in key value format, it is very easy. And when you want to search through or read a specific set of data, at that point of time you will have to scan through all these keys, only then you will get the relevant data. So, when you are trying to update or modify, the row stores are more apt, but when you are trying to search or when you are trying to retrieve or when you are trying to read, basically row store type of key value data may not be suited best. Whenever there is a row store, there is also going to be a column based store. Now, when we talk about column based store, each and every column will be treated independent of each other, and parallel arrays will be used for the purpose of representing column stores. Now, here what happens is, when you are trying to read the relevant data, only the relevant columns alone will be selected, but in case of row store it is not so. When you want to read a relevant data, the entire row is selected. Many attributes in the row may not be relevant for the projection purpose, hence you need to filter out, but this is not in the scenario of column store. So, when you are trying to read and then project the relevant data, column store finds to be more suitable and efficient. But when you are trying to write as a tuple, that is when you want to write as a single row, it becomes a bit difficult because you need to access multiple arrays simultaneously. So, when you are trying to update row by row, column stores are not very effective. Now, why do you require row store and column store? Whether it is a row store or column store, you require a key with which you are going to identify the exact values. So, in certain scenarios like retail domain, where you have various products and you are going to visualize all these products in various shopping carts, or wherever you have application in which you involve different products, or when you have different color schemes, an application where you have different color schemes, then you can always make use of this key value store type of databases. An example for key value store, in this slide you can find there are separate IDs, that is keys given to each and every row. So, ID 1 represents one set of values, ID 2 represents another set of values, order ID and order ID 57, order ID 56 and 57 represents another set of row. So, here you are representing two tables, supplier and order. In these tables, every row is going to be indicated by means of a unique ID. The second type of database is column oriented databases. Column oriented databases primarily work on columns, and every column is treated to be individual, that is they are independent of each other. Values in a single column are stored contiguously, and this is what is very much essential when you are trying to go for aggregation. So, for example, when you want to take the average, when you want to compute the sum, when you want to take the count, or when you want to identify the min or max type of aggregation functions, if you have the entire value stored in a single column and that too in a contiguous fashion, then it becomes for us to easily identify such aggregations. Such type of column oriented values are widely seen or used in data warehouse kind of environments and business intelligence, or even in customer relationship management CRMs environments. So, this slide provides you an idea of what is a column store. So, every column has got a unique value. When you take one single column, you may find set of values like Bob, Jack, or the values related to the column called name. The column called address internally has two sub columns. In other words, it can be two sub arrays, one highlighting the name of the city, another highlighting the country. So, the value for the city are New York, Paris, etc., and the values stored in the column called country are USA, France, etc. Likewise, every column will highlight a set of values. The next type of database is graph databases. In graph databases, when you compare this with relational database, whatever you call as a table or a relation in relational database environment, here it is called as vertices and edges. So, when you take a look at the diagram here, it is an example for a graph database where it is visualized in the form of a graph. So, each node in this graph can represent an entity like a student or a business or anything in the real world, and each edge that connects these nodes represent a connection or relationship between these nodes. Every node and edge in the given graph must be associated to a unique identifier. So, when we talk about rows, which is a common term in relational model, it is called as vertex or vertices in a graph model. Columns in a relational model is equivalent to key value pair in a graph database, and joins in relational database environment is equal to edges in a graph database. So, take a look at this diagram. Here we find various nodes highlighting entities like a particular person. The name of the person is Bob. The person is associated to an address. So, we have another node highlighting an address entity, inside which we have the city and the country name. The person called Bob is known to, or maybe friend of, or it can be follower of another person. So, here in this diagram you find a person named Jack, and Bob is considered to be a follower of Jack. The follower, which is the meaning of the relation, is highlighted as a caption. Bob is also associated to say two other entities. The two other entities are say the reviews that are posted by Bob. So, Bob has posted about two authors. The Bob has answered for a specific query in a particular blog. In the same website, Bob might have ordered for a particular product. So, the order ID and other details are here. The order may be associated for multiple items. So, the details of the items, everything is represented in the form of nodes and edges. So, this is how data is visualized in graph databases. Then the fourth type of database is document oriented databases. Document oriented databases is actually a collection of documents, and the data is stored inside documents. When we call something as a document, document comprises of key value pairs or key value collections. These key help in accessing the values that is present inside the document. Documents are stored into collections in order to group different kinds of data. Documents can contain many different key value pairs or key array pairs or even nested documents. In other words, document internally may contain another document. So, when you compare a traditional RDBMS and a document model, tables in relational environment are called as collections. Rows in a relation model are called as documents in document oriented databases. Columns in RDBMS environment is called as key value pairs, and joins are available in relational model, but it is not available in document model. So, a simple document oriented database diagrammatically can be visualized like this. Every ID over here indicates a specific document. You can find here the first document is all about an individual called Bob, another document is about Jack. Internally, the Bob document contains a link to another document called the order document. So, a document may refer to another document, or it may be a nested document even. There are many companies that use NoSQL. To name a few are the Google, Facebook, Mozilla, Adobe, Foursquare, LinkedIn, Dig, McGraw Education Publication and Vermont Public Radio. Now, all these companies have their data distributed across different locations. The data is going to be voluminous, hence it is distributed, and hence you require a storage environment that can handle unstructured and distributed data. So, in summary, we can say NoSQL is a successful type of database system that can handle huge amount of data, and especially which is going to be unstructured. NoSQL databases provide a mechanism for storage and retrieval of completely unstructured data, which is out of scope of traditional relational environment, and the data structures that is termed in RDBMS is completely different from that of a NoSQL environment, and you have separate type of accessing mechanism and querying for handling such unstructured data. Thank you.